Hi, this is a video of the presentation for my final year project. My final year project is about the golden code, which is a kind of space-time coding for multiple antenna system. The main goal of my project is to write a MATLAB code with multiple input, multiple output system with the Alamoti code and the golden code, and then evaluate the error performance. Look, this is a poster of my project. You can find it online. Now, let's look at the executive summary. This project can be separated into three different parts. First part is a literature study of multiple antenna system for 4G wireless and space-time coding, including Alamoti code and the golden code for multiple antennas. The golden code is a space-time code and work in multiple input, multiple output system. The study on the basic theory of multiple input, multiple output system and the space-time code will be helpful in understanding of the golden code. Also, the study of the Alamoti code will be helpful on the understanding of the space-time code. The second part of the project is writing MATLAB code about the multiple input, multiple output system using Alamoti code and the golden code to evaluate their error performance. During this project, the MATLAB code about the Alamoti code also be written first. The writing of the Alamoti code helps a lot on writing MATLAB code with golden code. The third part of the project is the analysis on their error performance. Now, before we move to the Alamoti code and the golden code, there are two things we have to know. First is multiple input, multiple output. Multiple input, multiple output is an antenna technology with multiple antennas at both input and output side. This figure here shows the model of the system. M transmitter antennas send information to N receiver antennas. Mathematically, the relationship between the send information x and the receive information y is y equal to h times x plus n, where h is the channel metric and the n is the noise. This equation will be used later. Second thing is about the space-time code. Space-time code is a code for the system with multiple antennas. There are two main types of space-time code: space-time trellis code and space-time flow code. Two space-time codes we used in this project are both space-time flow code. Now, let's look at the Alamoti code. Normally, signal sending transmission sequence is like this, where x1 is the symbol sent at the first time slow and x2 at the second time slow. However, in our system, we have two transmitter antennas, so look at this figure. At the first time slow, x1 sent from the first antenna and x2 sent from the second antenna. And at the second time slow, the negative complex conjugate of x2 is sent from the first antenna, and the complex conjugate of x1 sent at the first antenna. Therefore, you can get the code word of the Alamoti code like this. This code word is constructed both in space direction and the time direction. That is space-time code. Then, to get the received symbols, we have to do the following work. First, recall the multi-input, multi-output system relationship, which is y equal to h times x plus n. Then, use this equation in our system. We get the received information in the first time slow equal to this, and the second time slow equal to this. We put all these information together to get a new equation with x1 and x2 like this. To solve for x1 and x2, we have to find the inverse of h. However, this h matrix is not orthogonal, so we use the pseudo inverse of h, which is defined at this. Then we can get the estimate of the transmitted symbol is this. Now let's look at the golden code. The code word of the golden code is defined as below. To get a better understanding of the golden code, we put the code elements of the code word into x11, x12, x21, and x22. Where x11 means the symbol sent from the first antenna at the first time slow, and x12 means the symbol sent from the second antenna at the first time slow. If we do the same work as the Alamoti code before, we will get 4 equations with 4 unknown symbols, which can be calculated, but complex. Therefore, to get the received symbols, we use another way. First, we put the value of alpha and delta alpha into the code word, and then we separate the real part and imaginary part of the symbols, and multiply it by a matrix R to get a new code word X new, which is a 8 times 1 matrix with these elements. Then, to use the relationship for the multiple input, multiple output system, we have to rewrite the channel metric H to an 8 times 8 matrix, which is look like this. Then, we have to write the relationship in a new form, which is this. While this Y contains the information from the first antenna and the second antenna received in the first time slope and the second time slope. After this, we still do the inverse work to get this matrix with the 4 symbols separated in real part and the imaginary part. With the method above, I write the MATLAB code for the arithmetic code and the golden code in the multiple input and multiple output system. So in the next part, I will talk about the error performance for the multiple input, multiple output system with the arithmetic code and the golden code based on the MATLAB running results. Then, I run my MATLAB code for the system with arithmetic code and the golden code in 3 different channels. Let me look at the performance for the system with arithmetic code first. This system has the best error performance in the additive wide Gaussian noisy channel and has the worst error performance in the relay channel. And about the system with golden code, it also has the best performance in the additive wide Gaussian channel, and its error performance is very rare. But in the relay channel and the RISC channel, its performance is quite bad. So then I compare the error performance for the system with arithmetic code and the golden code in these 3 different channels. As the result based on my MATLAB code, you can see these 3 figures. The golden code has a better performance in the additive wide Gaussian noisy channel, but not in other channels. Therefore, based on the result get by my MATLAB code, I can get the following things. First, the golden code has a quite good performance in the additive wide Gaussian noisy channel, which means it's a good choice to use it in the system with this channel. However, the performance of the golden system with the golden code in other channels used in this project are not good, which means the golden code is not suitable for all the systems. In this project, I only use hard decision decoding MATLAB code, which is not a good choice. So for further consideration, the maximum likelihood decoding can be used to test the error performance of the golden code. Also, there are only 3 types of channels are used to test the error performance in this project. Other types of channels can be used to test the error performance to find which is the best suitable channel for the system with the golden code. Thank you for looking the video. If you have any questions, you can ask.